that we would have. And so that's a little bit easier way to go about it, but it's important to know both ways. So when we take a look at the ideal gas law, PV equals nRT, where N is the number of moles, R is the gas constant here. And this is the typical unit that we'll use. We're dealing with Kelvin, right, for temperature. Joules, with joules, you're going to be dealing with meters cubed for volume, pascals for pressure. And so this is typically what we'll use there. Some useful facts that we can have with this. The standard temperature and pressure we're going to be using is 0 degrees Celsius, 273 Kelvin. The pressure in atmospheres is 101,000 pascals. 101,300 pascals is 1 atmosphere, ATM. The volume of 1 mole of an ideal gas is 22.4 liters. So in other words, a mole that is at 0 degrees is all going to have the same volume. So this mole with all those molecules inside is going to have this shape, right? Which is also this in meters cubed. So in other words, 1 times 10 to the negative third meters cubed is the volume of an ideal gas. And if the amount of gas does not change, then we have this relationship there where the ideal gas before should equal ideal gas after. This is just missing N and R, right, on both sides, because both sides have the same number of moles. We can cancel that, divide that from both sides. R is divided from both sides. And those are the previous examples we had that. We must have kelvins for temperature, and then pressure must be absolute pressure. Okay, so 3 moles of CO2 are enclosed in a sealed container, 40 centimeters by 25 centimeters by 15 centimeters. If the pressure is 1 atmosphere, what is the temperature of the gas in the container? So go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. Okay, so here's our gas, PV equals nRT. 1 atmosphere is 101,000 pascals. Technically 101,300. Either way is going to be okay. It's going to be plenty close. The volume is 0.015 meters. That should be meters cubed, not meters squared. We'll set everything in there, and we should get a temperature of 60.73 Kelvin. So this would be very, very, very cold if this was the actual situation there. Okay. On this one, we have a 2-liter container that has 4 grams of H2, 132 grams of CO2. The container's temperature is 35 degrees Celsius. What is the pressure inside the container? So go ahead and pause the clip, see if you can solve this one. And when you're ready to check, you can hit play to continue. Okay, so CO2 is 40 to 44 U, so 44 grams for 1 mole of it. H2 has 1.00794 times 2, so 2 U. So therefore, 1 mole of that gas has 2 grams. So we know we have 132 grams of CO2. If we divide that by 44, we actually will find out that we have 3 moles of it. And then for H2, it says we have 4 grams, so therefore there's 2 moles of that because every mole is 2 grams for H2. So we have 5 total moles, and that may have been the toughest part of this one here. From there, we can figure out the volume. 1 liter is 1 times 10 to the negative third meters cubed, so that's the volume in meters cubed. Temperature needs to be in Kelvin, so we get that in Kelvin. PV equals nRT. We should, in the end, get a pressure of, what would that be there? 6,402,550 pascals. Okay, so using the ideal gas law, using the conversion with moles and grams, and then also looking at volume here in meters cubed. So I'll get there. So yeah, so hopefully all that solidified there for you.